So let's talk about debugging and optimizing without being evil. So you may have heard the phrase, premature optimization is the root of all evil. I think it was a Donald Knuth thing. And, this is one of those little pieces of information that's easy to learn. And so even like new developers know this. And for the longest time, I always thought that the phrase meant that premature optimization is bad because it adds complexity. It adds just extra cruft in the code, extra logic, or it makes things that could be easy to read really complicated in the hopes of saving a couple of cycles, a couple of little bit of memory here. But the more I've worked on it, the more I realize that premature optimization has another really big downside in that it can actually be counterproductive. So here is an article that I really love, and I've recommended this many, many times. It's called React Inline Functions and Performance. And it's a big article that goes over a bunch of things. But one of the big points that the author Ryan Florence makes is he was talking about something in React called pure component. So you don't see pure component very much anymore. But for a while, when you were extending classes, you either had component or pure component. And the difference is that component was kind of the default, and anytime the parent changed, the component would re-render. Whereas with pure component, every time, if the parent changed, it would compare the props and only re-render if the props changed. So he was discovered this new pure component, and it seemed like an easy win. So he went through and he changed all of the instances of component in his application to use pure component instead. And what he found was that when he re-ran the application, is that changing it to pure component actually made the application slower. So it was supposed to be an optimization, but what it did was actually make things slower. And he kind of thought about it and he realized that in a way it made sense, because if you have a component that re-renders every single time, that's just what it's going to do. But if it needs to check its props first, now it has to do two things. First, it has to check the props to see if it should re-render, and then it should re-render itself. So it actually made things slower, even though it's supposed to make things faster. And the point that he came to, which I think is a really good one, is if you aren't measuring, you can't even know if your optimization is better. And you certainly won't know if they make things worse. So the problem with premature optimization isn't necessarily the clutter, although that's some of it. But the big problem is if you don't know what you're measuring, if you don't have a baseline, it's hard to tell if it's going to make things better. All right, so that's why I've seen a lot of optimization strategies that kind of run like this. Sometimes I'll see code developers will put in, and I'll ask why it's there, and they'll say it's just faster, or this is optimized. And so a lot of the time, the optimization is based off of a guess or off of a certain prejudices that people have that they think certain things are better than others, but they don't actually know. There's no baseline, there's no comparison. So what I want to talk about today is a different optimization strategy. And so what it runs kind of like this. First step is you want to understand the structure of the application, just broadly, because you need to kind of start to think about where a problem can occur. Next thing, you want to profile a change. So you want to see exactly what the bad thing is, what needs to be optimized. After that, you can develop an optimization strategy, and then finally retest to make sure that it actually works. All right, so let's go through this. We're going to go and look at this using the React Developer Tools, which you probably have installed in your browser if you're a React user, very popular. But if you're anything like me, you probably didn't really use them to the extent that you could. There actually wasn't a ton of documentation about them. So we're going to kind of look at some of the features that are kind of like tucked away that you may not have noticed. All right, so this talk is based off of two articles I wrote for DigitalOcean. So one's called How to Debug React Components Using React Developer Tools, and the other is about performance pitfalls. So if you don't actually like to listen to talks and instead you'd like to read, most of the information is going to be duplicated in those places. Also a good place to reference. So I'll put those into the Meetup notes afterwards, some links if you want to check those out and refer to them. All right, so back to the developer tools. We're going to work with this application. And what it is it's a pretty simple application that does a few things. It has a text input, and you put in some text. It does a few calculations. So it calculates what the character count is, what the word count is, and this last one is the character map. And pretty much all it's doing is it's going through and calculating how many times a certain character is used, and then it's putting those in order of most to least. And so in addition to that, you can toggle on and off any given piece of information. So that's kind of the basic app. It's going to change a little bit as we go through it. But this is kind of what we're going to use to test different optimization strategies. All right, so the first thing we're going to do is we're going to understand the structure. We want to see how this thing is laid out. So if we look at it, we'll kind of see a layout sort of like this. Let me just go back over and pull that up. And you can see there's a lot going on here. So you can, if you've been working with React for a while, you probably recognize that the router here is a React router. And so there's this whole bunch of extra stuff until you actually get down, kind of just down here, which is where the good information is. And so part of understanding the basic structure of an application is you want to know essentially what can you ignore, because knowing what to ignore is actually almost as important as knowing what to look into, because there's, this is a pretty small application. If in your production application, there's probably hundreds of components nested in different levels of depth. It can get pretty hard to wade through. So what the first thing we're going to do is we're going to hide what we don't need. So in the settings, you can actually hide certain components. And so for by default, let me just pull this up. So the settings is here, this little widget icon. By default, it hides, for example, the div. So let's turn that off and see how that looks. So without, by showing the actual HTML components, it's hiding quite a bit to start with. So we'll hide those again. But we're going to hide a few more things, because for the most part, we don't really care about the router and the links. Maybe those are going to cause some performance problems, but for the most part, that's going to be pretty static. Generally, every application, for the most part, is going to have some sort of nav bar. The nav bar is going to be pretty static. You're not going to change it that much. So we're going to add a filter here, and I'm going to use the type name. Now, this is a regex. You don't have to put the little slashes in, but anything else goes. I'm pretty stupid with my regexes, so I'll just put in just the name of the components, browser router or link. And that should get rid of most of them. We'll get rid of switch too and route. So already this is starting to clean things up. This is going to make it easier to pinpoint different challenges that this application is going to have. Because now we're kind of segmenting out, we're black boxing those things that aren't really going to change. We're not really probably going to have a lot of problems with the router. Maybe we will, I don't know. But it's really just a bunch of extra stuff that's in the way. So another thing to notice is this name here, text context provider. This is a context that's going to share some information with these other parts. Now, by default, it doesn't actually have the name context provider. That's actually something you can add with the display name. So if you used to work with hardware components, this was used a lot to set the name of a component explicitly. Otherwise, it would just be this context provider, which if you have multiple contexts can be very confusing and very difficult to work with. So one of the suggestions is add the display names to things that don't have explicit display names. I wouldn't use the display name property on your components that are named. For example, like text information, you could still change the display name property, but then you kind of get this mismatch between what is the user sees and what is actually in the source code. All right. So the next thing I'm going to do is look at some of the state and the props. So for example, we know this is a provider and the value is set here. So let's go ahead and add some context here. Here is some content, and you can see the value updates. So in addition to changing it in the application, you can also just click on it directly and add some content. So keep an eye on the character count, and you can see that that's going to go up and the word count is going to go up. The information in the text input isn't actually going to change because the text input is what's setting that information, but you can set the value directly rather than use that. If I push a period here, it's going to override all the stuff I did before. All right, going down into the text information, you can see that this has a hook. The hooks, unfortunately, don't have very smart naming. I think there's a display name you can set there, but the docs actually encourage you not to do that. It causes some performance problems. So unfortunately, if you have a lot of hooks, you're just going to have to dig through the code to see. But much like with the context, you can change this. So we'll change the character count to false, and that'll disappear. Or if you click on a component, you can change the prop directly. So this is a Boolean, so we can turn it off and on. But it actually has this other secret prop color, which is used to set the color of the component. So we'll just change that to red, and that'll change it to red. All right, so a couple other interesting things here is that if you look at the hook, one thing you can do is you can copy that information. And this is nice if you're talking to someone, and it will show you what the name of everything is. So a good way to share information if you're working with someone else. Another nice thing is that it has the source of where the component is rendered. So if we're having problems with this character count, we can see that it is rendered here. We can copy that information. And then what it does is it copies the full path. So it copies the full path, and then we go to line 25. And there you go. So that's a really great way to kind of find out exactly what's rendering what and where. Makes it super fast. So you don't have to grab the code base. You don't have to do any of that stuff. You just copy it and you're in. All right, so let's do some optimization. First thing we're going to do now is we're going to profile a change. So let me quick show you the component that we're going to look at. The character map is going to be the one that causes all the problems. So here's the character map. What the character map does is it takes the context and it gets the text from there. It has the property of show. If show is set to is falsy, then it will just return null. Otherwise, it's going to map over the characters. And it's going to use this function called itemize. So this is where things kind of get a little dicey. So itemize is this function. It's going to take the text, split it so it's an array of characters, filter out any of the spaces, and it's going to loop over each characters, adding those to an object where pretty much it's going to iterate and count up as for each letter. So as you get more letters, it'll add them up. And then finally, it's going to sort them. So this function could probably be optimized. We're actually not really going to spend a lot of time on this. The whole point of this one is to assume that this is some sort of black box. Like this is something that's out of your control. Maybe it's a really slow API. Maybe it's a function that's already been optimized, but it's still like pretty expensive. This is just kind of a placeholder for an expensive calculation. And so we're going to try and figure out how can we optimize everything to kind of use that expensive calculation to use it as little as we can. All right, so let's profile. To start, I'm going to remove these filters because it's important again to see like how things look if you're not filtering out. So I'm going to remove those filters. Cool. And sorry, let me just go ahead and run the profiler. So we have our profiler here. I'll start it up. I am adding text. And then if you click that button, it'll stop it. So again, without filtering everything out, you really don't get a ton of information because it starts from the root application. So you get a bunch of these did not renders. That's not really helpful. So one of the things you can do is you can go on the ranked view, and this shows you which ones are the most expensive, ranks it from most expensive to least expensive, or the slowest to the fastest. But that doesn't really tell you much about how they're ranked together. So let's go ahead and turn that back off, or turn those filters back on, actually. And then clear that, we'll run again. This is more text. Stop that. And so now this is a lot easier to see. So we can see that the debug is changed, how long it changed, in that it renders this component, which renders this component, and then these three components are going to render in parallel. And the amount of time anything takes is for how long does it take for all of its children to finish. So you can obviously see that the character map is taking a lot of time. Now, another thing that I found like kind of a bizarre default setting is it doesn't tell you why things changed. So if you go in the profiler, one of the things that's nice is you can click this, record why each component rendered. So let's go ahead and rerun this. Start it up. Even more text. Stop it. And now if you hover over, you can actually see why any component changed. So in this case, the hooks changed, which makes sense. And for everything else, it's going to say the component rendered. So sometimes there's actually multiple reasons that a component would change, but I think there must be like a certain hierarchy of what they consider the most important. Because these would have re-rendered anyway because the hook changed, but this is still good information. So we can see that each of these re-rendered because the parent rendered. So that extra piece of information is going to be really important as we go through and start to profile things out. All right, got our filters back on. So next thing we're going to do is we're going to make this short. We're going to start making this so it has a lot of, so it's going to make it so it's really slow. So this is the text to the Thoreau essay, Civil Disobedience. And this one's nice because it's longish, but not like novel length. So it's just enough to give us some interesting information. So let me throw this in there. All right, so this is going to be kind of hard to experience because you won't, I'm going to make a change, but you're not going to see it. So you're just going to have to trust me. What I'm going to do is I'm going to hit an enter, and then I'm going to hit the letter E 3 times. So keep an eye on that character map, and you'll see when it changes. So enter, E, 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 waiting, 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 and there it goes. So this is, again, your first kind of clue that something's not optimized is really the experience. All right, so we know something's a problem. Let's see what happens if the text stays the same. So we kind of know like why that would be bad, because every time we add a new character, it has to recalculate that whole character map. Again, we're not going to focus on trying to cache information or optimize that. We're going to pretend that's a black box. But a little less obvious is what happens if we were to click this word count. So I'm going to click it, and again, just kind of see how long it takes for it to go away. Click, and it goes away. So there's a little bit of a delay, and it shows up again. Click, and in about 2 seconds, it shows up again. So in my mind, that's the problem. All right, so now we have a problem. We can start to measure it. Because remember, we're going to go back to this again. If you aren't measuring, you can't know if your optimizations are better, and you certainly won't know if we're making things worse. Well, we want to make things better, not worse. So let's profile. All right, so what I'm going to do is I'm going to profile toggling the word count on and off. So start the profiling, click the word count, shows up, and stop profiling. All right, so you can see that the whole thing took about, 2.8 seconds to render. That's pretty long, for toggling off something else. And when you look in here, you can see again that the main problem is this character map. This character map is taking a full second to render, which doesn't really make sense because nothing is changing. It's the exact same information. All right, so what are we going to do about this? So now we have to develop an optimization strategy. So this is where we're going to start leaning on some of the React helpers. So in this case, we have a slow component that doesn't change. So nothing about the component is actually changing. However, the parent triggers a re-render. So in this case, this is when we want to memoize the whole component. All right. So memoizing is, I realized I was in the wrong area. So we'll just go into the slow. Memoizing is kind of like the pure component I mentioned at the beginning. What it does is it only will re-render the component if some of the props change. So in this case, none of the props change, so we don't want to re-render the component. So I'm going to change that to memo. So all you got to do is wrap your exported function in this memo function. I'm going to go to the slow because that's where it's added. Let me copy this and paste it. All right, and so now we're going to reprofile. Actually, real fast, I'm going to show you first. You can see when a component's memoized because it's actually going to add that memo character on there. So that's kind of a helpful little clue if you're looking, especially if you're looking at third-party libraries. All right, so let's profile, turn the word count off, turn the word count on, much faster. So the whole thing took 0.2 seconds to re-render. And if you look and hover over this, you'll see that the character map did not re-render. They still have it there because it's part of the tree, but it didn't re-render. Text information hooks changed, but nothing re-rendered. So we know that this optimization actually worked. It's objectively faster. All right, so there it is again. And retest we did. So everything's good. Let me just kind of click through this. All right, so now we're going to simplify this component a little bit. So let me go to this next one. The new component is pretty much the same. The only difference is that we're going to have the show explanation, which actually says a little bit about what the component does. So let me show you how that looks and make sure I don't have a slide for it. Yep, here it is. It's kind of the same as before. We have a text and we have show explanation. We're actually putting in the text as a prop, so that's nice. Doesn't really change a whole lot. I forgot I made that. But the show explanation, if it's truthy, it will show the explanation. Otherwise, it will show the character map. All right. So we're going to change things a little bit here. Here's a performance thing in Chrome that I actually didn't realize existed until recently. You've probably learned about the network throttling. So this is a way of emulating if you have a slow network, but you can actually change the CPU throttling too. This is pretty nice if you want to emulate either a slow computer like the one I had that crashed, or if you want to emulate, like a phone. It's not perfect, but it's actually pretty good, I guess. And so this is essentially going to make your browser run with less memory. So I'm going to copy less of this text here, and paste it in. You can see already pasting take a little longer. So let's turn the explanation on and off. So clicked it, and it's really slow. All right, so again, it looks like we're going to have a problem here. So let's take a look at our plan. So we're going to profile a change. Let's profile a change again and see what's happening. All right, so back to our profiler. I'm going to clear this out, start profiling, toggle the explanation on, and stop it. All right, so in this case, we're looking through and the hooks change, which makes sense. The explanation props change. So this is a little bit different. Before it was only telling us that the parent re-rendered. Now we're seeing that a certain prop changed and it's telling us which prop it is. And then the character map changed, this is referring to both the memoized and the non-memoized version. And so explanation changed. So even though it was memoized, the props changed that makes the memoization no longer effective. All right, so now we have a problem. Let's develop an optimization strategy. Again, the key here is that a specific prop changed. So one prop changed, but everything was still going pretty slow. In this case, we have a slow component with a props changed. However, the prop is unrelated to an expensive calculation. So in this case, we can use the use memo hook for the expensive calculation. All right, so let's go and do that. So what use memo does, if you're not familiar with it, is it will only run a certain action when a certain piece of information changes. So we want our characters, and we're going to run the itemize function on it, but we only want to run it when the text changes. So if the text doesn't change, then don't run it. So this is like memo, but for a specific piece of information, for a specific calculation. So I'll go ahead and save that. And then let's go ahead and retest. So I'll start the profile, click show explanation, turn it off again. You can see already it's blazingly fast. And we have all the same information, but it's much quicker, 9.2 milliseconds. And we can still see that the props changed. So unfortunately, you don't really get a good clue about why a hook didn't run. It doesn't, at least if from my using this, if someone else knows better, please let me know. It doesn't tell you which hooks ran, but we can see that it's better. We have some objective evidence. All right, so there it again. The use memo is when you want to make sure that only a specific prop causes a specific actions. So it's much smaller in scale. All right, and here's the retest again, much faster. All right, so let's do another one where we have a slow component and multiple props change. So this time we're going to use this reference. It's pretty much the same. The big difference is that you will pass a function in to cause a change inside of the component. So that didn't really come out right. So let's just take a look at the code. Before we were making all of the text lowercase, but let's say, for example, that we don't want to do that. Maybe we want to give our users the option of converting it to lowercase or converting it to uppercase or doing some sort of other thing. So the user can pass in this function, which will take something and convert it to lowercase, and they're passing that in as a prop called transformer. So inside of character map, we're going to take the transformer. We want to pass that into our use memo because we want to recalculate the characters anytime the transformer changes. Because for example, if they wanted to change it, maybe you want to give the user the ability to toggle between lowercase and uppercase, we need to recalculate that. So we pass that into the use memo, we pass that into the itemize function. All right, so let's profile a change. Paste in our, oops, wrong thing. Let's paste in our information again. There we go. Clear this out, start it up, and click show explanation. And again, it's running pretty slow. So this time we hover over it. And this is a clue that something's a problem. Because now we can see that the hooks changed And, oh, interesting. I don't know why I didn't say hooks change last time. Maybe it didn't, I just missed it. Anyway, so the hooks change. So that tells us that our use memo ran. And we know that our props changed. So we know that both the show explanation and the transformer changed. So that's one of those clues that there's a problem here, because you really only expected the show explanation to change, because the show explanation was the button we clicked. So now we know, now we can see where we need to develop our optimization strategy. So we can see that there's two props changing. So we have our transformer here. What's going on is our transformer is a function. And even though this function is not being recreated, it's not referential, it's not identical. So if you've been working with JavaScript for a while, you know that functions and objects, if you compare them using strict equality, they'll always say false unless you are referring to the same one in memory. But if you make two objects that look identical, but compare them, it'll come back as false. And so that's a big problem. And actually, I think I realized I misspoke. It does recreate this function every time. That is the problem. So we need to be able to get around this. We want to make these things to be identical to each other so that when they are compared, they won't trigger a rerun. All right, so here is the strategy or font. We have a slow component that multiple props are changing, but really only one prop should have changed. That function should have stayed the same. So this is when we can either use the use callback or the use memo to make referential equality. We want these to refer to the same function in memory, so that way they will come back as identical when they perform the comparison. All right, so let me pop in the code and we'll do that. So that is in this reference, and we're passing in the function here. Use callback is a lot like use memo, in that it will run whatever's in here whenever something changes. In this case, we only want it to run once. We don't ever want this function to rerun, so we'll keep the array of changes empty. This would be the same as if you used use memo and you just made a function that returned a function. These are the same. Obviously, use callback's a little easier to read, so that's what we'll go for. So now what's happening is this const transformer should be the same. It should never be recreated. And now that we're passing it in the exact same way, we're not changing anything in character map because this is coming in as a prop. So character map doesn't really have any control over how it's created. All right, so we have this converted to use callback. Now let's go ahead and retest. We'll paste in our information here. Okay, start profiling, show explanation. Obviously, again, looks a lot faster. And interesting. So let's go ahead and look at it from a ranked view. So we can see the reference only took 1.6 seconds. Character map changed, but only because the show explanation changed. This time, it doesn't think transformation changed because the transformer was cached with the use callback, and we can see that there. So we also know that the hook didn't rerun. So things are clearly getting faster. We have evidence that they're working. And really, that's what it comes down to. Is it's just that easy? Of course, if you've ever done optimization, you know it's really not that easy. This is a contrived example. The reality is in your application, it's almost certainly going to be a bunch of tiny little things that are going to take a lot of little tweaks to get. So I found that like when I've worked on optimization, and the developers I've worked with who are really good at optimization, they kind of have like, you almost have to have this faith that the explanation is out there. You just have to believe it, even though it seems like impossible to find. So really the key to optimization in React is knowing the tools, but it's also really a mindset. It's knowledge that things will take time. So mentally allocate a lot of time. This usually isn't a quick afternoon problem. After that, the best thing you can do is start by sorting by rank. You always want to start with the worst contenders. And sorting by rank is a good way to do that because sorting by rank puts the hardest ones up top. And then from there, you can kind of see where they are in the DOM. Now, just because they're the slowest doesn't mean that they're actually the problem. Sometimes they're the slowest because they are doing the most and they have to do the most. But by starting with them, and then as you find out whether they are a problem or not, you can add them to the filter. So if you determine it's not a filter, get rid of it. Don't leave it in there. Don't muddle up the extra information. That keeps you from moving systematically. After that, hide slow interactions. So one thing I didn't show you is that in the profile, you can also hide certain interactions that take below a certain threshold of time. And I don't think this will probably work because everything's moving pretty quick now, but let's just try it. So let's profile. We'll run this, add some characters. It's going to take some time to do that. There you go. Show explanation and stop. All right. Let me make that a little higher because these took a little longer than I thought. So let's make the profile, we'll say 10 milliseconds. Hide anything below 10 milliseconds. So profile again, add a character here. Show explanation, turn that off. There you go. You can see it says that there's only one interaction, even though we know I did three things. I added a character, I toggled it on, I toggled it off. This is really helpful when you're working with an application that's going to have multiple effects on every change. Maybe you're logging something, you're updating a Redux store, you're re-rendering some components. A lot of stuff can happen. And so the more noise you can kind of filter out, the easier it'll be to kind of zero in on the problem. All right, hiding fast components is the same way. So that's kind of by rank. After you figure out that they're fast, filter them out. And crucially, there may be more than one problem. And this is, I think, one of the hardest things to get across to management or to any project owners is that the dream is always that you can find one component that causes 10 seconds of a delay. The more likely reality is you'll find 50 components that each contribute a half a second of delay or something like that. And weeding those out and optimizing those is really painful and takes the most amount of time. And then finally, when all else fails, make a page with as few components as you can. And then you can really start to zero it in. I was working on a really hard bug that was causing some problems in Internet Explorer and we couldn't figure it out. And so the only way I could finally figure it out was it was a form that was doing a bunch of stuff. I made a page that was only the form with only one field. And at that point, I was able to track it down into some of the third-party libraries. So unfortunately, it is third-party libraries sometimes. But the only way you can prove that is by eliminating anything else. So really, all these pieces of advice are about how do you eliminate things? And how do you use the developer tools to eliminate that? But again, the most important thing in optimizing and debugging components is to trust that there's always a solution. And that, I think, is the biggest change. The biggest difficulty in optimization isn't technical. It isn't tools. It's attitude. The people who are the best at it are the ones that don't give up. They're the ones that believe that there's something they can figure out. So there you go. That's my winning advice to get you motivated. Just trust there's always a solution. All right, so one last time, understand the structure, profile a change, develop an optimization strategy, including things like hiding fast components, whatever, and finally retest to prove that it works. Oh yeah, and this is all to say, unless you maintain a library. So I won't go into this because we're out of time, but if you maintain a library, that's when you do have to do the premature optimization. And for those instances, and this can include internal libraries, you do have to make some guesses about what's going to happen. And so using the use callback and the memoization, that becomes a lot more important because once you are something that's installed, it's harder for a user to go back and change things. So anything you pass into another component, a child component, should have some sort of caching attached to it. All right, we are actually almost at time. So I'm going to give my official thank you and goodbye. And then if you want to have questions, you are invited to stay on. So thank you.